Colette, you can begin.
Okay, want to go to next slide, please? Okay, before we begin, we have a few housekeeping items. All of you will be muted during the presentations, but please submit any questions that you have via the Q&A box, which would be on the bottom of your screen, and just make sure that you send it to all. This webinar will be recorded and made available on the New Jersey Brownfields Assistance Center at NJIT's website. And the web address is www.njit.edu/njbrownfields. Next slide, please. So good morning. I'm Colette Santasiri. I'm the Executive Director of the Center for Community Systems at the New Jersey Institute of Technology, as well as the Executive Director of the New Jersey Brownfields Assistance Center. Welcome to Redeveloping for Resilience, Transforming Brownfields for Community Resilience to Climate Change. The New Jersey Brownfields Assistance Center at NJIT is really delighted to bring you this webinar and the great speakers that we have. Joining me this morning are Jamala Harris from New Jersey DEP, Office of Brownfield and Community Revitalization, where she serves as the Community Collaborative Initiative Trenton Liaison. In addition, we have Jennifer Gonzalez, who is the Director of Environmental Services and Chief Sustainability Officer for the City of Hoboken, New Jersey. We have Ed Confair, who is the Senior Program Manager for Resilience at ENLP Associates. All of those three will be making formal presentations. Behind the scenes today, we have Sean Broom, who is Director of the Center for Community Systems, as well as the Director of the New Jersey Brownfields Assistance Center. And Sean will be facilitating the Q&A session a little later on in this program. Next slide, please. So with sea level continuing to rise, storms becoming stronger and more frequent, and flooding occurring more often than ever, communities are seeking ways to become more resilient to the negative impacts of climate change. Many of these same communities are plagued with brownfields. Some communities are tackling the problems of climate change and brownfields simultaneously by viewing the redevelopment of brownfield sites through the lens of resilience. The benefits of redeveloping brownfields for community resilience are many. From an environmental standpoint, contamination is remediated, public health concerns are lessened, and floodwaters are captured and then slowly released. Redeveloping brownfield sites for community resilience also addresses social equity issues. Minority and low-income communities are disproportionately impacted by climate change. These same communities also contain a disproportionate amount of brownfield sites. So ridding environmental justice communities of brownfield sites, alleviating floodwater impacts, and creating new land uses enjoyed by the community are positive outcomes in redeveloping for resilience. In today's webinar, we'll demonstrate how a couple of New Jersey municipalities have redeveloped brownfield sites that not only manage floodwaters, but also provide new land uses for the community. The webinar will also address land constraints and opportunities for implementing resilient development practices on brownfield sites. We will also be addressing your questions at the end of the presentations, but again, feel free to submit your questions at any time during this webinar using the Q&A box at the bottom of your screen. Next slide. So I've mentioned the term brownfields a few times. For those of you not familiar with the term, New Jersey state law defines a brownfield as any former or current commercial or industrial site that is currently vacant or underutilized and on which there has been or there is suspected to have been a discharge of a contaminant. So that's the official definition, and I'm sure many of you have seen brownfields all throughout this state. Brownfield sites include old mills and factories, abandoned chemical plants and junkyards, and other former industrial properties. The closed gas stations and auto repair shops, former dry cleaners, and some other vacant commercial properties are also considered brownfields, again, because of their past uses or the type of building materials that were used for their construction. So that's That's what brownfields are. We're going to get into introducing our speakers and hearing about the great work that they're doing. So if we go to the next slide, our first presenter is Jamala Harris, who is the New Jersey Department of Environmental Protection, Office of Brownfield and Community Revitalization, Community Collaborative Initiative, Trenton Liaison. Jamala, take it away.
Good morning. Thank you, Colette. Again, my name is Jamila Harris, and I work for the New Jersey Department of Environmental Protection in the Office of Brownfields and Community Revitalization. So this morning, I'm going to quickly go over with you brownfields and resiliency, green infrastructure on urban sites. I'm going to review a case study that we have worked on in the Office of Brownfields and Community Revitalization in the community of Camden, New Jersey. Next slide, please. So a little bit of background about my office, the Office of Brownfield and Community Revitalization. Our office is broken up into 4 sections. The first section is the Hazardous Discharge and Site Remediation Fund, or HDSRF. So the HDSRF fund is a public fund that has dedicated allocations from the New Jersey corporate business tax every year. So since about 1993, the HDSRF fund has provided grants and loans to public, private, and nonprofit entities totaling about over $400 million. The HDSRF fund offers funding for a preliminary assessment, site investigations, remedial investigation, and remedial action work at contaminated sites. This fund is jointly administered by DEP and New Jersey EDA. The next section of our office is the Brownfield Development Area, or BDA program. So since about 2002, the DEP has managed the BDA program, which offers a really unique approach to remediation where there's 2 or more sites remediated at the same time. So these sites are assigned a BDA manager, and this manager assists the municipality with the DEP regulatory process. The next section of our office is the Landfill Redevelopment Program. And we know in New Jersey, a landfill redevelopment is at a premium, and some municipalities, the only land available for development is landfills. So the landfill redevelopment section of our office works with a municipality ensures that the landfills are redeveloped in a manner that's protective of the human health and the environment. Next slide, please. So the next section of our office is called the Community Collaborative Initiative, or CCI. And CCI is a bridge between DEP and 12 municipalities in the state of New Jersey. And the projects that we work on in CCI are partnership-based projects. And these projects promote quality of life in some of New Jersey's most distressed communities. So CCI really works in the community with a boots on the ground approach. And we try to ensure that equitable economic development and enhanced public outcomes serve these distressed communities in New Jersey. Next slide, please. So I'm going to talk a little bit this morning about brownfields and green infrastructure. I know we reviewed the definition of a brownfield, and it's just any former site that's commercial or industrial that's vacant or underutilized, and which has been or suspected to have been a discharge of a contaminated. And next, the definition of green infrastructure. It refers to ecological systems, both natural and engineered, that act as living infrastructure. And green infrastructure elements are planned and managed primarily for the stormwater control, but they also have social, economic, and environmental benefits. And green infrastructure, it really incorporates the natural environment as well as engineered systems. And it definitely provides an economic boost to the neighborhood that they serve. And some examples of green infrastructure can be rain gardens, permeable pavements, green roofs, tree and tree boxes, as well as rainwater harvesting systems. Next slide, please. So what exactly is a rain garden? So a rain garden is essentially a garden that collects rainwater, holds it for a limited amount of time, and filters it slowly back into the ground. And it collects this rainwater from impervious surfaces like roofs, pavements, driveways, patios, parking lots. I'm sure we've all familiar with the type of runoff that occurs when it rains. So the first 2 inches of the rain that falls off of roofs is the deadliest because that rain carries non-point source pollution. And I'll just give you a quick example of the non-point source pollution. Those are pollutants that are picked up and carried by runoff. So some examples can be motor oil, gasoline, fertilizers, chemicals, herbicides, and even pet waste. So these things can run off into the streams and waterways, and the rain garden's job is to absorb it and slowly filter it back. Next slide, please. So how did this project come to our office in OBCR? So Frank McLaughlin, he's the supervisor here in OBCR. He was attending various community meetings in the city of Camden where he worked as a BDA manager. So some of the projects he worked on in Camden were the Kramer Hill BDA and the North Camden BDA. So he has a very boots on the ground approach where he actually engages the community and wants to know about their environmental concerns. So in 2008, the local community residents as well as nonprofits came to Frank and OBCR and CCMUA, and they said that they had a gas station in their neighborhood that was really having an environmental impact in the neighborhood. And this community in Camden is called the Waterfront South community. So that's a very distressed community in that section of the city of Camden. And the residents felt like their concerns were not being addressed. This area of Camden was subject to extreme flooding, which interfered with school travel, work travel, and it really had an impact on the quality of life of the residents. And just a little bit of background about the type of flooding, this area is considered to be a CSO community, a combined sewer outflow community. So when it rains, you're not just dealing with rainwater, but you're dealing with water that contains raw human sewage and various forms of wastewater. So you can imagine the distress that it really caused this community every time they had a rain event. And they were really fed up and they decided to come to Frank and say, hey, this gas station is a problem for us. It floods really badly and we don't know what else to do. And in addition to the gas station causing flooding, it was a blight on the community. When you have blighted, abandoned sites, not only does it attract dumping, but it also attracts other illegal activities, and it can increase the chances of crime in a neighborhood where things are abandoned and neglected. Next slide, please. So it definitely takes a village to execute a project like this. So I'm just going to go over some of the partners that worked with us to have this project initiated. So again, in OBCR and DEP, we leverage the strength of our partnerships. That is a hallmark of how our office operates. So some of the partners that we worked with were the Heart of Camden and the Center for Environmental Transformation. Both of those organizations are local nonprofits that advocate for residents, for environmental justice and sustainable practices. And they really prioritize this gas station as being an issue in this neighborhood. We also work with the Camden County Municipal Utility Authority, or CCMUA. They're a regional sewer authority that worked along with DEP, and they were able to purchase the actual gas station and had a hand in overseeing the rain garden creation. Of course, various entities within DEP worked together to achieve this project. The Camden Redevelopment Agency, they were an agency that were able to fund the PASI-RI work through an EPA grant. And we in our office at OBCR worked with that agency to kind of get the remediation of the site expedited. We also worked with Camden Smart Partners, which included the City of Camden, Hooper's Ferries Partnership, Rutgers University, and the New Jersey Tree Foundation. And Rutgers University actually had a hand in designing the rain garden. So it was a really nice collaboration between all of the entities. Next slide, please. So now that you have your partnerships in place, now you look to the funding piece of the project. So in 2007, DEP's Compliance and Enforcement and Camden County Municipal Utility Authority, or CCMUA, agreed to a supplemental environmental project settlement of $655,000 for an air violation at the CCMUA plant. And just a quick background on what a SEP, a SEP is. A SEP is when the DEP, Compliance and Enforcement, works with the violator and they offer that violator an opportunity to correct the violation. And the monies from the settlement go toward a project in the neighborhood in which the violation occurred. But this project has to provide a strong environmental benefit for that neighborhood. So both parties, DEP and CCMUA, agreed that the SEP monies from the violation should go to a project in Camden Waterfront South neighborhood. That was a big, big lift as far as the funding piece. In addition, OBCR worked with CCMUA to actually purchase the site from the owner. The owner was unwilling to do any remediation at the site, despite our efforts and compliance and enforcement to compel them to do so. So OBCR was actually able to negotiate this, the sale of the site to CCMUA. And again, in 2008 and 2009, OBCR also worked with the Camden Redeveloping Agency to secure a $100,000 EPA Brownfields petroleum grant to help investigate the site. So again, that's where a federal partnership, our partners at EPA come in with additional funding for the project. Next slide, please. So now that you have your partnerships in place and your funding in place, the work can begin. So this is just a depiction of the beginning of the creation of the garden. A total, since it was a former gas station, 12 underground storage tanks were removed, 1,850 tons of contaminated soils were removed. There was an extraction of a diesel sheen on the groundwater, and clean fill was placed at the site. Again, OBCR worked very closely with the LSRP on this site to oversee and make sure that the SEP monies were used properly. Some of the SEP monies were used to demolish the building, remove the tanks, and remove the contaminated soils at the site. Next slide, please. Next slide, please. Here. And then in previous slide, I'm sorry. So this is just shows you the evolution of the project. You can see in the top corner, the gas station was abandoned for over 15 years. So you can imagine the blight and the effect that it had on the neighborhood. And you can see the progress of the site. The tanks were removed, the contaminated soils were removed, and then the contaminated soil piles were staged for disposal. So OBCR and CCMUA worked very closely together to create 4 rain gardens on this site that manage anywhere from 500,000 to 800,000 gallons of stormwater annually. So it really provided a strong environmental benefit for this community. Next slide, please. So this again shows the evolution of the site. You see the abandoned gas station, the tank removal and soil removal, and again, the beautiful garden that turned out at the end of the project. And really, this was a first of its kind project for the state of New Jersey, where you take a contaminated gas station and turn it into a garden. So a lot of parties were unsure that a project like this could be done. But once we had our partnerships in place and our funding in place, we were able to move forward with executing this project. Next slide, please. Again, a before and after. And what I really love is that it shows that this become a jewel of the Camden Waterfront South neighborhood. As you enter this neighborhood, there's a sign that welcomes you to the neighborhood, and it really improved the quality of life for these residents. They went from not being able to actually even take their kids to school when it rained to having a park that can be enjoyed for their family. Next slide, please. So this just shows a schematic of the rain garden. There are a total of 4 rain gardens there. Again, it manages from 500,000 gallons to 800,000 gallons of stormwater a year. And the design was provided by Rutgers University, another partner. The park opened Earth Day 2012, and it provides about a ½ acre of green refuge and really a gateway jewel for this community that also manages local stormwater flooding. So again, some of the hallmarks of this project were securing strong partnerships, sometimes working with nonprofits, and also being creative as far as how we were able to get the design done and the funding for the project. So when you have all those pieces together, it really gives you an idea of some of the transformational projects that can happen in Brownfields. Next slide, please. So thank you for your time. If you have any questions about the project, please feel free to email myself or Frank McLaughlin, and I will turn it back over to Colette.
Well, thank you so much. Thank you, Jamala. It's a great example of transforming a brownfield, in this case, a former gas station, and putting it back into productive reuse for the community's enjoyment, as well as dealing with floodwaters and flooding in Camden, New Jersey. So thank you very much for that. Our next presenter is Jennifer Gonzalez, who is the Director of Environmental Services and Chief Sustainability Officer for the City of Hoboken. Hoboken employed a comprehensive water management strategy focused on parks as defense to mitigate flood risk, and the use of brownfield sites was central to that strategy. So I'm excited to introduce Jennifer and hear all about the great work that's being done in Hoboken, New Jersey. Jennifer?
Hi, everybody, and thank you, Colette, and thank you to NJIT for inviting Hoboken to be part of this session today. So just a quick intro to where Hoboken is in case anybody's not familiar. We are located directly across the Hudson River from Midtown Manhattan. We're about just over 1 square mile, 60,000 residents and 27,000 households with a $9.7 billion rateable base. We are actually the 4th most densely populated city in the United States. And as such, we have an interesting kind of environment where we can test a lot of strategies for brownfield remediation, flood mitigation, and climate adaptation. We're small, but we have a lot of capital projects in the works, and I'm excited to share a lot of them with you today. This map is from 1890, and you'll see it later in the presentation. What I find interesting is that the floodplain is virtually mirrors what the floodplain is today. This area kind of on the west side of the city, it was tidal marsh. Hoboken was actually originally an island, and all of this was filled in the early 1900s. And this is largely the area that is most flood prone today. Hoboken ranks in the top 100 of National Flood Insurance Policy or NFIP communities. We have about 10,000 insurance policies that cover almost $2.3 billion in assets. And that's basically 1 out of every 3 households that's required to have flood insurance in Hoboken. We are planning for the future. We have a climate action plan, as well as a comprehensive water management strategy that we'll talk about today, all of which accounts for approximately 2.5 feet of sea level rise by 2075. We were significantly impacted by Hurricane Sandy. We had more than $100 million of individual assistance claims and 25 million of public assistance claims, with significant damage to homes and vehicles, as well as public buildings. And that's kind of an example of our coastal flood risk from storm surge events. But more frequently, we are flood risk to rainfall flooding. This is an image of the intersection of 10th and Madison Street in Hoboken, where we frequently experience rainfall flooding during any rainstorm that brings us more than 0.8 inches of rain per hour. We consider that to be our threshold for an intense rain event, and that's when you'll start seeing flooding in our most low-lying areas, which are on the southern and western parts of the city that I showed in the previous map. So this image shows our comprehensive water management strategy that was developed in partnership with the Department of Housing and Urban Development right after Superstorm Sandy. They had a design competition that brought some innovative thought leaders from around the world to develop new solutions for flood risk mitigation. And we took that time, which was actually coincidental with a study that the city had been doing on a green infrastructure strategic plan, to really look at what our risk was and also what our environment is. So we're largely built on historic urban fill. As I said, the west side of the city is filled in. We're very low lying, with some areas just above sea level. And the highest part of the city is kind of on the eastern side, what some of you may know as Washington Street, our main street, and Castle Point at Stevens Institute. And then the lower part of the city is on the western side. So what we were challenged to do is find a way to resist coastal storm surge, which infiltrates Hoboken at the lowest lying areas, down in the south at the Long Slip Canal. This is where the NJ Transit Terminal is. And at the north at Weehawken Cove. And so during Superstorm Sandy, storm surge came into the city and really filled up Hoboken like a bathtub. So it came in from the north, from the south, and flooded the entire west side of the city, about 2/3 of the city, more than 500 million gallons of water. It took us about 2 weeks to recover, just to dry out, and then the actual recovery process started then. And we've been planning for coastal and rainfall flood mitigation really ever since. So this strategy, in partnership with the federal and state government, will resist coastal storm surge That portion of the project is actually being undertaken by the state, by New Jersey DEP. They have the Rebuild by Design Hudson River project that's going to implement a levee to resist coastal flooding. And the city is responsible for the stormwater flood mitigation components of the project. That is the delay, store, and discharge components. So we're working to delay stormwater from infiltrating our combined sewer system, store it in the system during the event through these large resiliency parks that basically act as sponges to keep water out of the storm system, and then discharge it actively through wet weather pumping. And all of this is done in partnership with our sewage authority, the North Hudson Sewage Authority, that owns and operates the combined sewer system in Hoboken. So, as Jamila said, it does take a village. You have to partner with other organizations. So a lot of our resiliency efforts that we'll be talking about today are in partnership with the state, federal government, the North Hudson Sewage Authority, and all of our local stakeholders and nonprofit organizations. So I'm going to focus today on our parks as defense because all three of these parks were brownfields and they are all now being redeveloped into resiliency parks. We have one existing park at Southwest. Two existing parks, one at Southwest, which was our first park, opened in 2017, 7th and Jackson Park, which was opened in 2019, and Northwest Resiliency Park that is currently under construction as we speak, slated to open in 2023. We'll start kind of at the north end of town with Northwest Park, and that'll be the primary focus of the presentation, and I'll touch lightly on the other two towards the end. So Northwest Park, as I said, is in a location with historic fill. Most of Hoboken is historic fill. And it was a low-lying marsh prior to 1910. Then it was filled, which created this land for industrial development. And from about the 1920s through 2000, it operated as a chemical manufacturing plant, Henkel Chemical. And you can see kind of some images here of the historic factories. A lot of Western Hoboken was this industrial use, and actually our waterfront as well. Maritime industry was very significant. When we looked to redevelop this site had been identified in our master plan as a new park. And we have really employed the strategy that every new park that's developed in Hoboken cannot just be a park, but can also be a flood mitigation measure. So when we received the site, it had already been capped by the prior owner. This is an image from 2016 when we acquired it. But we said, okay, there's this giant, effectively parking lot, right? How are we going to turn that into a beneficial use for flood mitigation and open space? So during the period of design, we actually built a pop-up park, which was a temporary park that was on the site from 2017 through 2019 while we worked on a very significant engineering design with Ed Confair from ENLP, who will speak in a moment. The design process was lengthy because this is a massive infrastructure project, and we wanted to make sure that the public benefited from the park in that meantime. So we developed this pop-up park, and it was actually a really great asset to do community engagement for the design of the permanent park. So the site had been temporarily capped, as you saw in the previous picture, and our design team's philosophy was effectively, let's keep as much of the soil on site as we can. So we needed to make room for the water. This image depicts the underground tank that you'll see in a moment, where we excavated the soil and actually kept it on site to create topography and create a really interesting park design. And real kudos to ENLP and Olin, who developed this innovative park design for the city of Hoboken. The soil that was kept on site then became the topography, which was then capped with a variety of different surface treatments, whether that be pavement for plazas or sidewalks, grassy areas, the fields that you'll see in a minute. So we kind of had a variety of different types of capping that are being, as we speak, reinstalled on the site. So the original asphalt cap that was done by the prior owner prevented obviously rainfall and water from reaching the contaminants below the park. So obviously we want to restore the cap And in doing so, we'll be installing at least 2 feet of soil and vegetation that will serve as an engineering control to protect public health and safety. But we'll also consolidate everything that can be kept on site. Of course, some soils did have to be removed, but we did manage to achieve zero net fill and keep as much on site as possible. In doing so, creating a more natural cap for the site. And this is what the site will look like. This will be our largest resiliency park at about 5.5 acres, and it will feature a multi-purpose athletic field with a series of rain gardens. We'll go into on other slides. A basketball basin that also stores stormwater, a play valley, and a central civic terrace that is actually the main elevated portion of the site, under which a lot of that soil was moved, and then a great lawn for events and movies. As a bird's eye view of the site, and I can't wait to put this next to what it actually looks like in 2023, but we will show you some current pictures of the site under construction. This is the basketball basin that I just referenced. I just wanted to give you 2 renderings that kind of showed you how this area was excavated and depressed, whereas this kind of civic terrace was actually elevated. And so, we were kind of moving soil around efficiently to make sure that we met the net fill requirements, but we also had to haul away as little as possible. In summary, here's really the impact of the park in terms of climate adaptation. We are storing 1 million gallons of water in an underground tank. We are also managing more than 750,000 gallons of stormwater on site through rain gardens and green infrastructure. And there's also a cistern that will be used to irrigate the site that will store 50,000 gallons of water. We have about 300 trees that are going to be planted on the site, and a 90% reduction in combined sewer overflow events as a result of this park's stormwater management measures. So this is the 50,000 gallons cistern under construction. It has long since been covered up. This was about 1.5 years ago, this photo. And this is the 1 million gallon tank under construction. You can see it's a series of chambers that have been kind of like Legos, pieced together and grouted together. And here's a view from the north. It is almost the size of a city block. This park is kind of a super block. And so the tank takes up about half of it, but you would never know it from looking at the park as we stand today. Here are the chambers, view from underground, and this is actually a view from inside of one of them. So, well, the tank, not just one. And those are kind of the features that are underground, doing the flood mitigation work while also keeping this brownfield site capped for recreation purposes, and also turning it into a very beneficial use for our residents who are demanding open space. So moving on to 7th and Jackson Park, the unique thing about this site was that it was entirely developed by a private developer. This field is on top of a series of PVC pipes that you'll see in the next slide. It is just about a 2-acre project. It stores 466,000 gallons of stormwater runoff, developed by a private developer and then turned over to the city. It was part of a larger redevelopment project. This is the image of the types of pipes that are actually underneath that field. And so we were able to do this at no cost to the taxpayer. And, through this redevelopment process, we were able to both, leverage in kind of an innovative way to finance the project, but also have the project built by a different, third party. We now operate and maintain the park. And we do so in partnership with the North Hudson Sewerage Authority that maintains the underground infrastructure for stormwater management. And very similarly, Southwest Park, our original resiliency park, which was also a brownfield. This is what the park currently looks like at the surface. All of these pavers are permeable pavers. These are rain gardens. There's a series of rain gardens, stormwater trees, There's also a cistern on site, underground detention, similar to 7th and Jackson, which manages, all told, the permeable pavement, the stormwater trees, the cistern, the tank, altogether is just under 200,000 gallons of stormwater management on the site. I should have noted that the former use at the 7th and Jackson Park was a levelor blind factory. And the former use at this property was a parking lot. There were previous industrial uses prior to that. So that's a little bit about our brownfields remediation, and I welcome you to email me with any questions. Our website is there, and on that website you can find links to specific project pages for each of those 3 parks, as well as our overall flood mitigation and climate adaptation strategies.
Okay, thank you so much, Jennifer. I want to thank Jamila and Jennifer for giving us some great examples. And as you can see, they're very different examples. And we chose those, by design. Jamila's example was a small site. It was a gas station that was sitting for years, and the community wanted something done. And plus they had flooding issues and they needed something done there. Whereas the example of Hoboken was a citywide strategy, very different, looking throughout the city, how do we handle floodwaters, and then looking at using the parks as defense as their strategy, and looking at their brownfield sites. And the reason why we chose these very different examples is to show communities that there are many different ways of dealing with these issues, and many different ways of viewing the redevelopment of your brownfields through the lens of resilience. So thank you again, Jamila and Jennifer, for those examples. Now, before you go out and start digging up your brownfield sites and putting resilience parks and rain gardens, we need to consider a lot of different things. Consider what's on the property. Consider what types of green infrastructure can be useful. Consider the engineering involved. So our last presenter is Ed Confair, who is the Senior Program Manager for Resiliency at E&LP Associates. He's going to speak about different opportunities as well as constraints for the implementation of resilient development practices on brownfield sites. So Ed, take it away.
Thank you, Colette. So like Colette said, my name's Ed Confair. I am a professional engineer and landscape architect, and my firm E&LP Associates has been working for the last 5 years with the city of Hoboken on the Northwest Resiliency Park, which Jennifer showed. So I'm excited to get into some of the nuts and bolts from the design perspective on realizing some of these resiliency projects on sites that are often constrained, such as brownfields. So I'm going to touch at the beginning here on just kind of the bigger picture planning perspective of approaching these sites, then get into the typical constraints we often see and have to design around, and then the tips for overcoming those challenges. I like to start these presentations about resiliency with statements like this, which really tie into what Jamila and Jennifer were saying, which is, our communities are transforming. We know we need to adapt to climate change, and where we can find overlap with our public spaces, blight, places that we want to redevelop, and we can find the synergies to do those things together in a planned fashion. We really have an opportunity to address the performative aspects of resilient design and the social ones. As Jamila said, these places can really transform a community and become a hub for a neighborhood, in addition to all of the flood mitigation and stormwater benefits to be had. So this is a approach we took in all our work, especially on the Northwest Resiliency Park site. And so starting with planning, there's a lot of guidance and documentation. Everything you'll hear me say today, you can find details on from state DEP guidance documents, universities like Rutgers, organizations like New Jersey Future. You can look at nearby out-of-state cities like New York and Philadelphia, which have excellent guidance document. You don't have to start from scratch or reinvent the wheel. There's a lot of smart people and organizations that have put together really comprehensive guidance on planning and designing green infrastructure systems. So to use an example, looking at what Hoboken did with Northwest Resiliency Park, the point I want to make here is to look at both your master planning, your comprehensive plans, your recreation open space inventories, overlay them with the most recent flood mapping and your infrastructure inventory, such as your CSOs, if you're in a CSO area, coordinate with your municipal utility authority on where your sewer sheds are, where your stormwater systems are. And the point is you're looking for synergies and overlap. So if you're from a municipal point of view, you want to find where you own land or where there's blighted land or brownfield land that can be of use to where you're also having flood or resiliency issues. And then you want to pair that with the social aspect. Community engagement is an incredibly important part of these projects, getting public buy-in, making sure people feel safe, that you're creating places of refuge, that you're improving their neighborhoods and that you're listening to them, to what they want to see on these areas as they're improved, that you're kind of programming the sites in a way that you're filling gaps for amenities that may be missing in neighborhoods are all important aspects to getting public buy-in. Online surveying is a great tool, and you'll eventually develop kind of a suitability analysis of what makes the most sense at different sites. So if you can kind of build these layers together, I promise you that there's a functional stormwater resilient design, whether it's something below grade, surface, if it's a system for reuse, if it's a building green roof, et cetera, that will match up with your community's desires for gathering spaces, community center buildings, playgrounds, sports courts, fountains, et cetera. There's a stormwater solution that goes along with each one of those social amenities. So with that big picture thinking in mind, going to start to dive into some site-specific constraints. Right on the right side of this diagram, these are just a snapshot of things that come up from the design perspective that your engineers and landscape architects are dealing with. Right, we've got a balanced cut fill, we've got to recharge water, we've got to worry about design flood elevations, et cetera. At the same time, we want to be taking care of community assets, making sure sites are accessible, activating them with different types of recreation, taking into account transportation. Can we have an educational and signage component on these sites? So it all ties together. So kind of first constraint, you're in a low-lying flood hazard area, right? As Jennifer showed with the Northwest Resiliency Park, you've got an area that floods, whether it's in a minor case or an extreme case like Hoboken. And you really want to approach this at two different scales. You've got green infrastructure, rain garden systems, shallow vegetated systems. We'll have more photos coming up, but if you think about the photos Jamila showed, these are kind of small surface level systems. These aren't going to manage the superstorm standees. These are going to take care of your 90% rainfall event. That's going to have a big impact on your communities and taking care of local nuisance flooding. And then when you have the superstorm standee, then you're looking at these larger flood mitigation projects that might involve below grade tanks, pump stations, et cetera, to mitigate. So if you have a structure on your site, you're going to look at floodproofing. There's a variety of ways to approach this. You can wet floodproof a building. So that means you're allowing it to get wet. And I'm saying building here, but it could really be any type of structure, playground structure, pavilion, bandstand, et cetera. If it's in a wet area, you have to know that the materials you're building out of can withstand that. You can dry floodproof a structure, which means you're going to kind of put a shell or materials that are resistant to water up to whatever your design flood elevation is. You can do kind of a hybrid approach where you try to raise the structure as much as possible, but acknowledge a certain height is going to get wet. Or you can attempt to raise the structure out of the floodplain completely. This might result in kind of what you're starting to see as a typical kind of building condition in condos in Hoboken or Jersey City, where you're walking down the street and you're seeing all of these stairways, right, up to the first floor of residential habitable spaces being elevated above the street level due to design flood elevation considerations, right? And then things like parking, where it's okay for water to come in and flood those areas, are on the ground floor, and people's habitable living spaces are elevated. So these are kind of becoming common architectural strategies. The other thing I want to mention, this is an example of the cut fill analysis for the Northwest Resiliency Park site, is if you're in a floodplain, you want to balance cut fill. If you overfill a site to raise your building or structure out of the floodplain, you are adversely affecting your neighboring properties by displacing that flood water onto them and exacerbating their conditions. So Jennifer, mentioned this and showed some of the really nice renderings from our project. And this is kind of a peek into the backup engineering data that went into kind of setting that elevated civic terrace and then figuring out how much we needed to depress the other areas of the site to maintain that balance. Another common constraint, shallow groundwater, right? If we're in a low-lying area and groundwater is elevated, then how are we creating enough storage space for stormwater if the groundwater is already taking up that location? So this is an example of a site that floods frequently on the Schuylkill River in Philadelphia. I'll come back to this in a second to show you the after, but one of the common solutions is to line a system and have an under drain layer above the liner. So it's not infiltrating, but it's still creating that storage capacity. And the important thing to do here is to make sure you're balanced with the weight of soil, under drain, and planting material you have above the liner layer, so that you have enough weight to resist the hydrostatic pressure of the displaced groundwater that would be pushing up below the liner. So you can't go fully into the water table, but you can go in a foot or so with a line system if you have enough weight of soil on top of it. And this is going back to the Schuylkill River site. This is what was done at this site. There was a liner. We're about 6 inches into the water table, a stone under drain layer, and then the planting soil profile. This site regularly gets inundated. It manages the small events, and when the Schuylkill jumps the banks, it's none the worse for wear. This site's about 4 years old now, still functioning very well. An example of what you'll see this time next year in Hoboken at the Northwest Resiliency Park is the largest basin in the site along Madison Street. And I really wanted to show this one just as an example of how to activate a rain garden area and make it a public amenity, right? Because it might seem like a lot of space to give to something that's just managing stormwater. And so from a design perspective, we always want to ask, what are the stormwater systems doing when it's not raining, right? In New Jersey, we probably have 50, 60 rain events per year. So that's a lot of days per year where the systems are actually dry. And the more we can activate them with floating decks, boardwalks, pathways to get people into the systems around kind of the created natural environment and engaging with them, the better. So this is kind of an example of how to do that. Now, you might also have shallow groundwater, but you need a very deep system, right? So this is an example of the same 1 million gallon tank that Jennifer showed. The point I want to make here on it is, this system is almost 30 feet below grade. So this is a really different type of kind of groundwater mitigation strategy. This has large sheet piles all around the tank to create the void space and keep out water to make this installation. You might also make the pile wall out of concrete. It's called a secant pile wall. But just build on what Colette said before I started, is you've got to know if you're in a small kind of at-grade rain garden situation like Jamila showed, or if you're in a city or neighborhood-wide flood mitigation strategy like what Jennifer showed, because they'll have vastly different engineering constraints and costs associated with them. So another frequent brownfield issue is no infiltration. These can often be clay soils. There might not be native soils left. You might just have compacted historic fill and construction debris. You might have contamination that you don't want to infiltrate because you don't want to mobilize the contamination and have it travel off-site by introducing stormwater. So common constraint to run into. The liner solution that I already mentioned is one way to deal with this. Another option is to focus on water quality. So you can still excavate, as Jamila and Jennifer showed in their photos, to create space for underground or surface storage. But you want to make sure you're still getting the water quality benefits. So there's different technologies that you can wrap these underground pipe systems in to still get your state required TSS removals, nutrient removals. You can really focus on the soil media that you're backfilling these systems with to make sure you're still getting all of the water filtration aspects in addition to the volume storage. And that kind of leads right into dealing with on-site contamination and capping. Again, it's very common, depending on the outcome of a soil investigation on a site, to have to cap a brownfield site after it's been redeveloped with a new use. So you need to do very thorough soil and groundwater sampling. You'll work with an LSRP, a licensed site remediation professional in the state of New Jersey. This is an example of the plot of the investigation on the Northwest Resiliency Park. So you're going to look both horizontally for where you're getting hits in plan, as well as depth-wise to know how deep you might be constrained. And then you might find that if it's a small area, the best thing to do is excavate it and remove it off-site, like Jamila showed, or it might make sense to keep it on-site, like Jennifer showed. So if something's widespread, you might be in a situation like on the left, where you can have a relatively level area that you're capping with asphalt or concrete, and you're putting a sports court or a plaza on it. Or you might consolidate it into an area to create topography, and then also simultaneously free up other below grade area for stormwater storage or other uses. I want to show another example from 1600 Park Ave in Hoboken. This is an example, Jennifer brought to our team's attention at the start of the Northwest design process, which is, a capped soil mound to keep this material at the location it was excavated from, and then it's still activated with a public amenity. And the pop-up park, before construction on Northwest started, is another example of activating a hardscape cap. So in New Jersey, there's a term, presumptive remedies, that are in the remediation rules. So these are different depths that are acknowledged as being effective environmental caps. So 12 inches for asphalt is an effective cap, and you can still make a vibrant public place out of it. And then the basketball basin. I just wanted to touch on this one from the design perspective, because it's one of the more unique and exciting features of the Northwest Park. So this area is going to provide 2 feet of stormwater storage, while also having a lined bioretention basin cap compliant design surrounding it, and the asphalt court surface itself is a cap. So you've got 2 different caps transitioning between them, and it's serving an important stormwater function, and it's still completely activated as a usable public amenity. So it really hits everything that all 3 of us are talking about here today. Another option, kind of common way to activate a brownfield site and how to effectively cap it, is multi-purpose athletic fields. With synthetic turf, stormwater can go right through this, and really your only limitation is how deep you can go and how much stormwater you want to store beneath these types of fields. You can fluctuate the size of the storage pipes in the stone media. If you're worried about contamination, you can line the system. If you're not worried about contamination and you can infiltrate, you can leave the liner out and provide that storage and infiltration, which is the best case scenario. But then these areas still get heavily programmed and activated and are really important community spaces. Again, another option, engineered wood fiber. Right? As long as we have these upper kind of material things, there's a lot of flexibility of whether this is soil, planting, wood fiber, permeable pavements, cobble pavers, etc. And we can build up additional depth below those to become CAP compliant. So this is an example of building up from a site. This can also be done at grade. An example from the Northwest Park design, the lowest area on the site is actually the playground area. And so this is about an acre of engineered wood fiber underlain by a stone and pipe underdrain layer, and then an HDPE plastic liner and clay below it as the capping system. So it's providing stormwater storage, and the overflow from this goes to the on-site cistern that Jennifer mentioned. And then another two things that frequently go together, they don't have to though, is kind of urban redevelopment and having limited room, right? You might have a defunct building that you don't want to knock down. Maybe you're keeping it and a developer is going to renovate it and rebuild it, right? So an option in space constrained situations is to go vertical and do a green roof on top of a building, or a blue roof as well. And then these could just be there for stormwater purposes, like you're seeing in the example on the screen, or you can also make this a public amenity with walkable spaces, pedestal kind of paver plaza areas to activate it for residential use as well. Think linearly if you're space constrained, right? Not all the stormwater systems need to be a basin. You'll hear that word a lot. You can fit bioretention systems in roadway medians, along the edges of roadways, like in Washington Street in Hoboken. This is an example of a stormwater bump out under construction at the Northwest site. And there's a lot of ways to manipulate a standard kind of detail for a tree trench. You know, if there's contamination concerns, you may want to line it as this detail is showing. If there's not contamination concerns, the important thing is to just have a continuous linear trench for plant and tree root growth, and then allow infiltration to take place. So you can still get all of the green infrastructure benefits from long linear systems as you can from a concentrated, smaller footprint. And then just technology-wise, you know, providers of stormwater system devices and products understand that we're running out of space and sites are space constrained. So think about using things like flat drains. So these are much wider and much shallower in depth, and they're an alternate to a traditional circular pipe. And they might save you, you know, 5 to 8 inches on depth in an under-drain system. Really great option. If you're in a more structural application, again, you're on an industrial site or manufacturing, you're going to have a lot of truck traffic in the redevelopment scheme coming through. There's also really shallow structural systems. I've seen these kind of plastic grid systems as shallow as 6 inches to work with a paving profile. And so they're also really space efficient. They're near 100% voids, but they're structurally sound and will take truck traffic. So there's a lot of new technologies to be aware of and that you can deploy on sites as well. So just in summary, you know, plan at the front end, make sure you're overlaying all those different maps that are available to you. Be prepared for typical site constraints. Make sure you've done your due diligence in your soil and groundwater testing. And then be ready to use a variety of kit of parts. Each one of the examples I just showed has been put into effect in some way in the Northwest Resiliency Park. So it's not a one-size-fits-all approach to kind of resilient design. And that's it for me.
All right, thank you so much, Ed. Thanks for pointing out the constraints, the challenges, as well as the solutions. You've given us a lot to think about, so we really do appreciate that. Before we open up to Q&A, and we've left a lot of time for that, I just wanted to make mention that the New Jersey Brownfields Assistance Center at NJIT is partially funded with a grant from the New Jersey Economic Development Authority. And because of that funding, we're able to bring you this webinar as well as other webinars that we've held in the past. We record all of our webinars and store them on our website. So feel free to go to our website, www.njit.edu/njbrownfields, to see any of those webinars. I also want to make mention that the New Jersey Brownfields Assistance Center at NJIT provides free technical assistance to any public entity or nonprofit that is dealing with brownfields. If you have any questions or you have the need for assistance, please reach out to us. Again, if you go on our website, you'll see the contact information for myself and for Sean. You could call either one of us, send us an email, and we're here to help you. So with that, I'm going to turn the program over to Sean, who's going to facilitate the Q&A.
Thank you, Colette. Unfortunately, we have no questions, but if anybody does have a question, please put it into the Q&A pane, and then we will get to them as they come in. I do have actually a question for Ed. You mentioned in some of the green stormwater infrastructure systems that if there's a contamination issue, that you can put a liner at the bottoms of these systems. I guess my question would be, for those that aren't familiar with these systems, is there a long-term issue? Like, do contaminants accumulate and then there's a maintenance issue with those systems for removing them, or are they typically contaminants that dissipate through natural attenuation? If you could maybe explain that a little bit for those that aren't familiar, including myself.
Sure, yes. The short answer is both are possible. So sometimes it can be beneficial to introduce water into certain contaminants to dilute them and dissipate it, especially if groundwater impacts are not an issue. You know, if it's just soil contamination, there can actually be benefits to introducing water. So that's an option. If that's not an option and you're lining to separate the engineered soil and under drain layer from the contaminants in place, there's a couple different types of liners. You could do a clay liner. You know, the Northwest Resiliency Park is an example of a clay liner with also a plastic sheet liner above it. So that kind of forms a barrier from any stormwater getting to the contaminants or mobilizing them. And then everything above the liner is clean fill that's being brought in from off-site. So when water runs across whatever the finished surface is into the basin or the stormwater feature, it's only tracking, you know, solids or particulates that aren't contaminated into these features. So we're not worried about new contamination coming in, and the liner is keeping existing contamination from being mobilized or affected by what's happening above the cap layer.
Okay. I mean, the reason I asked that too is because I'm somewhat familiar with the area, and I know that the Long Slip Canal is just south of Hoboken, and I'm not sure the condition of the water quality as well as the sediments in that canal. And during a storm surge, is that an issue if that water, you know, gets pushed in through the canal and then into these systems? So that was kind of why I was curious about that.
So if water, so if water in a storm surge situation, if water from off-site is overflowing from an area that it may be bringing particulates of concern onto the site, there's a couple protections for that. So if you have a vegetated system, the depth of that soil is there particularly to remove TSS and provide pre-treatment. So that's one way to combat it. There is maintenance in that regard. You know, the systems do have to be monitored on a monthly basis. If there's accumulation of sediments, et cetera, at the surface level, those should be cleaned and removed from the systems. If it's a below grade system, it's actually probably a little easier to maintain because there will be an inlet point into the below grade system. And that structure would have what's called a sump on it. So it's got an area below the pipe that goes into the system. So that allows any of that inflow trash or debris to be accumulated at that low point, and it can be cleaned out regularly, and it doesn't make it up over the invert into the system itself.
Okay, great, thank you. We do-
Sean, before you continue, Jennifer and Jamila, would you put your cameras on and unmute yourselves? And Sean, you could put your camera on as well, so people know who they're talking to.
There we go.
All right, thanks.
Okay, so we have a question here. How do you measure if the mitigating projects are working? Is there a way to quantify this? I don't know who wants to jump at that one.
Right. Jennifer, talk about what we're doing at the park.
Maybe you want to talk about Northwest specifically, and I can talk about kind of Opti sensors in general.
Yeah, sure. Right. So as an example, at the Northwest Park, we have a variety of protocols. So, there's things called observation wells and clean outs that are essentially ports down into the subgrade parts of these design systems. So those are regularly inspected for standing water to make sure they're draining appropriately. So there's a visual inspection component. There's also the cistern on site, which all the overflow is being routed to. That's tied to the irrigation system, which has sensors, et cetera, built in. So we'll know how much water is in the system and in the cistern specifically, and being recirculated to the site on a daily basis through that software and setup. So that's another indicator. And then we're also looking to locate different types of sensors in the outlet control structures and the inlet points of the systems that will log data for the city to evaluate things like water quality, water depth, et cetera.
Jennifer, did you want to add to that, or?
Yeah, so just kind of as a broad systems approach, we have employed in partnership with the North Hudson Sewerage Authority Opti sensors, which are effectively a brain for the underground detention tank. So the Opti sensors will measure volume that's in the tank as well as outflow to the sewer system. So we have Opti sensors at Southwest Park and 2 at 7th and Jackson Park. There will be one temporarily at Northwest Park until the pumping station goes online. And we have the ability to see all of these on dashboards. So in real time, we can see how much water is in the tank, how much water is flowing out to the sewer system, and how quickly that's happening. After every intense rainfall event, North Hudson Sewerage Authority actually provides the city with a breakdown of how all of the tanks functioned, how all of our wet weather pumping stations functioned. And so it's a very close partnership because they're responsible for operating and maintaining the tanks, the sensors, the pumping stations, and they share, data with the city as well. So, we have an ability to do that. They're automatically controlled based on real-time weather data. But, should there be a need to manually control them, we can do that as well. So NHSA can do that as well, I should say. So that's kind of how we monitor those. But Northwest Park is really going to be the first park where we measure water quality. We don't have any real, tools to measure water quality at 7th and Jackson or Southwest right now. We have done a little water quality measuring at our City Hall rain gardens. But other than that, Northwest will really be a key test for us to see how we can truly measure the quality impact of our resiliency parks.
Okay, that's a great question and great responses. Does anybody else?
Yeah, I have a quick answer.
Sure.
I can actually get the information for you, Kaylin, but I know for the rain garden in Camden, it's actually maintained in partnership by CCMUA and the Camden Smart Partners. So I can definitely get specific on you on how they quantify that.
Okay, another question is somebody's interested in where they can find more information about the rain garden. So I'm assuming they're referring to the ones you discussed today, and maybe you guys can add some more resources for just rain gardens in general as a resource source.
I just popped into the chat the website for the Camden project. So if you'd like to take a look and see a little bit more information on our rain garden, you can definitely check that out.
I will do the same right now.
Other resources to look at is the New Jersey BMP manual for stormwater is available online, has whole chapters dedicated to rain gardens. It's termed bioretention there. But it's that type of system. University of Rutgers has really good guidance, freely available, construction details, calculation methodologies, etc. That's a great resource. New Jersey Futures, another local one. They have both good resources for developers and municipalities on design of stormwater systems. So those are three local and state ones that my office uses all the time, in addition to our just own internal accumulated knowledge to see what other professionals are going by as standards.
I have a question. Jennifer, could you briefly list all the different sources of funding for the work that you're doing in Hoboken on these parks? Because I'm sure it's costing a lot of money.
All is lengthy, but
The main ones.
Yeah, no, I mean, again, it takes a village, but of funding sources. So I actually have a presentation that I'll post in the chat too, specifically about how we finance green infrastructure. But in general, we do a lot of work with the New Jersey Infrastructure Bank. The Clean Water State Revolving Loan Fund has been a great source for us, not just for low interest or 0% interest loans, but also for principal forgiveness. So the Northwest Resiliency Park, going through the infrastructure bank, has actually saved the city over the length of the debt service of the project about $16 million. And the total construction of the project was $48 million. So, going through the iBank is definitely significant savings for us over the 30-year term. In addition, we have, West Park specifically, been awarded grant funding through FEMA's BRIC program, which is Building Resilient Infrastructure in Communities, for cities and communities. So the FEMA BRIC program is expanding rapidly, and my understanding is through the infrastructure bill, it's expanding even further. So I would definitely encourage communities, especially if you're just in the planning phase, to look into BRIC, because they offer both planning and construction grants. We've also had grant funding through the Hudson County Open Space Trust Fund. We have an open space trust fund as well. And in a lot of our green infrastructure projects, we partner them with transportation projects or drinking water projects, so that we're able to leverage a variety of different funding sources together. So, for example, we constructed 15 rain gardens on Washington Street. A lot of that was funded through NJDOT local aid, Tiger grants, as well as iBank funding too. So I think we've had a variety of different kind of one-off grants, like the National Fish and Wildlife Service funded some grants for Southwest Park. And the last would be private developers. The 7th and Jackson Park was funded through a redevelopment agreement in which we provided increased density for an adjacent redevelopment project in exchange for the community benefits of the park and actually a community gymnasium that was constructed all as part of a full redevelopment project. So New Jersey Future and Jersey Waterworks, as Ed said, are great resources. They have guides on funding. They have grant resources online, and they have a redevelopers guide if you're looking for how you could kind of marry public-private funding to construct green infrastructure and also brownfields redevelopment. The New Jersey Redevelopers Guide to Green Infrastructure is a great resource. So I'll post that, and I'll post our financing presentation in the chat.
Thank you. And I just want to add to that for brownfields, there's various funding sources to plan for, assess, and remediate your brownfield sites. So on the federal level, the US EPA has a number of brownfield grants. New Jersey, there's the HDSRF that Jamala had mentioned. Also, the New Jersey Economic Development Authority has a brownfield funding program. as well. So if you have any questions on those specific programs, again, reach out to the New Jersey Brownfields Assistance Center and we can walk you through those grant programs. I think, Ed, you wanted to mention something?
Yeah, I just wanted to mention a recent grant I saw that I believe is still active through DEP, is the Regional Greenhouse Gas Initiative funding. So that one has both blue and green projects that you can submit. So if you're a coastal community, you'd be in the blue section. So anything related to flood mitigation, stormwater that we're talking about is eligible. And if you're more back from the coastal areas, their green projects, again, are meant to prioritize park projects, tree canopy planting, stormwater management, green infrastructure. So kind of everything that you saw today. If you have that type of project, it would be eligible. And I've seen more and more various DEP grants for water quality, non-point source pollution, et cetera, over the last couple of years. So, keep an eye on DEP's website for opportunities.
I just wanted to add to that really quickly. And you just have to really be creative when you look at these projects and definitely leverage your funding sources and look for projects that have more than one outcome. And that's a good way to segue into getting funding. So just, a little bit of out of the box thinking, and definitely also utilize your partners. Maybe they can take on different pieces of a project. So it really all comes together kind of like a puzzle sometimes.
Good point.
Okay. That's it for the questions, Colette.
Okay, I just want to ask our presenters, does anyone want to say anything else, either about your project or about this topic in general? Any words of wisdom, lessons learned? No, you said it all.
I mean, I would echo Jamila. I think everything is about leveraging partnerships, and that leads you to various funding sources. So our partnerships have really been the key to every one of our projects. And community engagement, I should say too. Got to have the buy-in from those who are going to benefit.
Ed, Jamila, any porting?
I would also second what Jennifer said. It's really the community engagement piece was very important because our project in Camden, we weren't aware that the community had such an issue. And so it took, although Frank initially was working on one section, he was actually a BDA manager in his capacity. He learned about various environmental issues. So I would really implore to just kind of, if you're going to service a neighborhood, kind of canvass the neighborhood, see what the environmental issues are, and really, put your ear to the ground and listen, and it can take you a long way. So I encourage the combination of partnership and community engagement. As we can see, all these projects have such a wonderful outcome for the state of New Jersey.
Yeah, I'll third that. I mean, communication and multiple people have said it takes a village. On the design side too, our consultant team for Northwest is 13 different firms all working together. That vision that doesn't include, the construction management firm. It doesn't include the team for North Hudson Sewerage Authority that we've been working with. I mean, the amount of design professionals that touch projects like these to make sure all the due diligence is done and we're really being thorough is immense. So communication, all working together, kind of having that vision is just the make or break of the whole project.
Great, thank you. Sean, any new questions come up or?
No, that's it.
Okay, well, with that, I want to give a very big thank you to Ed, Jennifer, and Jamila. Thank you so much for your time today. Thank you so much for your wisdom and experience and for sharing all of that with us. Thanks, Sean, for your role in this webinar. And thanks again to New Jersey EDA for the funding that supports these webinars. And again, if you have any questions about Brownfields or anything you heard today, please reach out to the New Jersey Brownfields Assistance Center at NJIT. With that, thank you so much for everyone who joined us, and enjoy the rest of your day.
Thank you.
All right, thank you. It's been a pleasure.